Assalamualaikum and hi everyone. We are from A4S 120513. Our case study for Chemistry 260 is about HPLC-UV method for quantification of favipiravir in pharmaceutical formulations, written by Ibrahim Bulduz. Now, let's meet the teams. The first one is Nur Umairah binti Ahmad Fauzi with the number ID 2020815906. The second one is Afif Vikram bin Muhammad Shah Haizam with the number ID 2020481652. The third one is Zulaika binti Anwar with the number ID 2020452264. Let's start with the introduction first. Firstly, our problem statement is how to analyze quantitative and qualitative analysis of favipiravir in HPLC-UV. Next, for the objective, first to determine the retention times of favipiravir in active pharmaceuticals ingredients. Second, to analyze the concentrations of favipiravir in active pharmaceuticals ingredients from the area in standard calibration. Favipiravir, or the IUPAC names is 6-fluoro-3-hydroxypyrazine 2-carboxamide, is an analog of pyrazines. As you can see, there's this chemical structures of favipiravir, which is there's this benzene ring with 2 nitrogens, which is the chemical structures of pyrazines. Favipiravir, or we call FVP, inhibits the RNA polymerase of RNA virus selectively, which preventing from viral reproductions. After pilot trials in Wuhan, Musti Zhongnan hospitals discovered a higher recovery rates in COVID-19 patients in FVP groups compared to arbitol groups, which from these trials, FVP considered was to further investigations as potential candidates drugs in this disease. FVP is not officially available in any pharmacopoeia. Thus, a validated HPLC is developed to determine the FVP in pharmaceutical formulations. It will be determining the FVP assay and imperative in active pharmaceutical ingredients. HPLC is a rapid, simple, precise, accurate, and isochromatic high-performance liquid chromatography. The UV detections that we use have wavelength and column temperatures of 323 nanometer and 30 Celsius. Under these chromatographic conditions, the runtime was 15 minutes. Next, for the method validations, we use system suitability, which is checking of a system to ensure a system performance before or during the analysis. Second, the linearity that evaluates by least square linear regression analysis of the average peak area versus concentration data. Third, the limit of detections LOD and the limits of quantifications LOQ, which determine using the standard errors and slope of regression lines. And fourth, accuracy that can be confirmed with the recovery studies which conducted by the standard addition techniques. Fifth, for the specificities is the ability of the analytical method to produce a response for the analyzed in the presence of other interference. And this next, positions that can be analyzed by calculating variations of the methods in intraday and interday. Intraday lies for a days, and interdays is you calculating the variations in a few days, which is 3 days. Lastly, robustness, which to determine the impacts of minor yet systematic difference in chromatographic conditions.
Okay, next we move on to methodology. For the first step is preparation of stock standard solution. First, 100 mg of pure drug was accurately weighed and dissolved in about 30 ml of deionized water, and then transferred to a 100 ml of volumetric flux and add deionized water until calibration mark to obtain 1 mg per ml of stock solution. The stock solution then was sonicated and filtered through a 0.45 micrometer filter. The stock solution then was diluted with deionized water to obtain the required concentration of standard solution, which is 10 to 100 microgram ml, before being injected into the system for analysis. Next is preparation of sample solution. 10 FVP tablets were accurately weighed and transferred to a dry and clean mortar, and then ground it into the fine powder. Next, tablet powder equal to 250 mg FVP was transferred to 250 ml volumetric flask. In about 100 ml, deionized water was added and flask was attached to a rotary shaker for 10 minutes. And then the mixture was sonicated for 30 minutes and dilute until calibration mark with deionized water to give a solution containing 1000 microgram per milliliter and filter through a 0.45 micrometer filter. Determination of lambda max. To obtain lambda max from the UV spectrum, standard solution 40 microgram per ml was scanned between 200 and 800 nanometer on spectrophotometer. The next is chromatography condition. Chromatography analysis was performed on a column of inert cell ODS3VC18. The mobile phase was filtered and degassed through a 0.45 micrometer membrane filter before use and pumped at flow rate of 1 ml per minute. The column has been thermostated at 30 degrees Celsius. The runtime was 15 minutes under this condition. The mobile phase in this chromatographic condition is potassium dihydrogen phosphate and acetronitrile. The analytical method validation has been performed as per ICH guideline of validation of analytical procedure. First is linearity. First, standard calibration has been prepared using 6 standard solution, which is concentration range of 10 to 100 microgram per ml. Each standard solution was chromatographed for 50 minutes 3 times. Least square linear regression analysis of the average peak area versus concentration data were used to evaluate the linearity. And the second is selectivity. The selectivity of the method was tested by comparing the chromatogram obtained from the FVP standard, tablet, and blank solution. The parameter retention time and tailing factor were calculated. It is proof that the method chosen was specific. And next is limit of detection LOD and limit of quantification LOQ. These values were determined using the standard error and slope of the regression line. LOD 3.3, LOQ is 10. And next is precision. For the precision was analyzed by calculating variation of the method in intraday and interday. What is intraday? Intraday is repeatability performed by analyzing standard solution on the same day, while interday, repeatability carried out by analyzing standard solution on 3 different days. Precision was performed by injecting 6 times of standard solution at 3 different concentrations, which is 20, 40 and 60 microgram per ml on the same day and 3 consecutive days. Next, we move on to accuracy. In this method, 80%, 100% and 120% of 3 different levels of pure drug were added to the previously analyzed sample solution. And favipiravir recovery was calculated for each concentration. Next is robustness. Modification include different flow rate of the mobile phase, acetonitril ratio in the mobile phase, and column temperature. After each change, system suitability parameter were checked by injecting the sample solution into the chromatography system, and the result were compared with those under the original chromatography condition. And lastly is solution stability. The stability of the sample and standard solution was monitored over 24 hours period. For this, standard and sample solution were injected into the system at 8 hours period, and the peak and retention time were evaluated. During the stability study, standard solution has been stored at ambient temperature, which is 25 degrees Celsius, and protected from the light.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fikram and I am going to show you the result of this. So firstly, we have the maximum absorbance, and the maximum absorbance lambda max it to be found is 300 millicurie nanometer. So the maximum absorbance we get it from absorbing the peaks of the standard solution on its UV spectrum. So you can see the peaks right here, and that's how we get the 333 nanometers. Next, we have the calibration curve. So the calibration curve, we firstly to find the calibration curve, we standard solution concentration at the range of 10 to 100 microgram milliliter negative 1 was obtained by diluting FBP with the ionized water. So we get the calibration curve from plotting the graph of concentration against the peak area, and that's how we get the calibration curve. So to find the x, we use the formula mean peak area y equal to a, which is the the y-intercept, and then we have the b, which is the gradient, and of course the x, the concentration. So from that we found the correlation to be 0.999, the slope for 9.122, and the intercept 82.593. So the concentration is found to be 82.598. So the lack of fit test P we found is that is equal to 0.0516. That is more than 0.05. This means that it met the condition of linearity. So next we had the LOD and LOQ value from table 1, which is 1.20 over 3.60, and that it also met the condition where LOD should not be more than 3.3 while LOQ should not be more than 10 as per meter. So this means that the analysis was unbiased and precise. Next, we have the selectivity. So from the chromatogram A, B, and C that was shown, there is only one peak at the same retention time of 7.696 minutes. So while chromatogram D represents the mobile phase. And from this, the retention time, theoretical plate number, and peak tailing factor were calculated. And they are 7.696, 13798, and 0.920 respectively. And they are all within the range of acceptance. Next, we have the precision. A precision test was done by injecting 20, 40, and 60 microgram milliliter negative 1, and the concentration of standard where it was all done on the same day for 3 days in a row. From table 2, we found that all RSD value peak area and retention time are less than 0.5 and 2%. This means that this method is very precise. Next, we have the accuracy of the method. So to find the accuracy, the sample was treated with 80, 90, and 120% levels of standard solution. So the percent RSD value obtained were less than 2%, meaning that the accuracy of the method is great. So next, we have the robustness of the mobile phase. So from the result in table 4, the change in voltage flow and column temperature does not have any significant impact toward the percent RSD readings. And while the change in acetonitrile ratio, however, it was a small change in percentage RSD reading. This means that the mobile phase is very robust. After that, we have the solution stability. So for 24 hours, the stability of the sample and standard solution was monitored. During that period, changes in peak area and retention time are observed in an 8-hour interval. So the percent RSD of peak area at 8 hours was 0.275, while percent RSD of retention time was 0.115. This shows that there are very little changes in the sample and standard solution, which proves that these solutions are very stable. So lastly, we have the application of this method. So this method was treated with marketed tablets, and as shown in table 6, the method was able to determine close to the actual amount of FVP that was labeled on the tablets. This means that this method can be applied and very precise indeed. And that's all from me.
Lastly, for the conclusions that we get from this analysis, HPLC method was developed for determinations of FVP with ICH guidance. The method was very interesting because of its short run time, which is 50 minutes, retention time 7.6969, and mobile phase flow rate, which is 1 milliliter per minute. These features save analysis times and money, as a buffer potassium dihydrogen phosphate has a variety of intercuring properties. These characteristics include good buffering capacity in the pH range chosen, ease of availability, low toxicity and cost, and greatly improved spreadability without colon degradations. For FBP impulse and tablets, this method is sensitive, selective, reproducible, and fast. The maximum quantification is as low as 3.60 micro per milliliter, and this shows that the analytical method is robust and reliable. That's all from us. Thank you.